Good day. This is the cybersecurity team from SeaNet. In this session, we will walk you through a practical case study based on the Samsung Heavy Industries SN2666 series, which achieved the Lloyd's Register Cybersecurity Established notation. This is not a theoretical overview, but a real project covering the full life cycle, from gap analysis to onboard testing. And our objective is to help shipyards and ship owners clearly understand what is actually required to implement and achieve cybersecurity compliance on board. This session is structured into two main parts. First, we will cover the project information, including background, requirements, and the Lloyd ShipRight framework. And second, we will go through actual execution results, such as onboard testing methodology and key observations. This case is particularly meaningful because it represents a full end-to-end implementation following the gap analysis phase. This project involves crude oil tankers built by Samsung Heavy Industries, specifically the SN2666 series, consisting of 2 vessels, and the classification society is Lloyd's Register, with Cybersecurity Established Level 1 notation applied. SeaNet participated as the system integrator, covering both documentation and onboard services, meaning the scope included the full certification process, rather than simple equipment supply. The systems in scope include bridge systems, such as ECTHIS, machinery and cargo systems under IAS, and communication systems, such as VSAT, covering major OT domains on board. The key point of the Lloyd established requirement is that it is not limited to device-level security, but requires a risk-based cybersecurity approach across the entire OT environment. And based on the gap analysis conducted by Netitude, additional requirements were identified for each system, along with corresponding remediation actions and evidences. The Lloyd ShipRight process consists of 4 phases, including project planning, initial assessment, client remediation, and final assessment. And from a system integrator perspective, the most critical phase is client remediation. This is where all action points identified in the gap analysis must be addressed and implemented. And these actions are documented in the Remediated Action Report and Vulnerability Testing Report, which serve as key inputs for the final assessment by Lloyd. The gap analysis is conducted by Lloyd's third-party partner, but the important aspect is not simply reviewing the results, but interpreting each action point into practical and implementable tasks. For example, requirements related to access control, remote access, and logging must be adapted depending on each vendor's system architecture, so the system integrator plays a critical role in coordinating between the shipyard and vendors and translating these requirements into feasible implementations. The Remediated Action Report is one of the most critical deliverables, and for each action point, it must clearly describe what actions were taken and include supporting evidence. The key is not simply stating that an action was completed, but demonstrating it in a verifiable manner, such as providing configuration screenshots for account management or actual policy settings for access control. Under Lloyd requirements, vulnerability testing is not just a standard scan, but must be conducted based on the actual network architecture, including both vulnerability scanning and port scanning. In particular, for port scanning, it is essential to verify whether each open port matches its intended function and aligns with the asset inventory, meaning it is not sufficient to identify open ports, but necessary to justify why they are open. The overall scope of work includes documentation and onboard survey, where documentation covers preparation of all reports based on gap analysis results, along with evidence collection. Onboard survey involves verifying systems on board and conducting vulnerability and port scans. And particularly for VSAT systems, testing must be performed under controlled and coordinated conditions due to external network connectivity. One of the key factors in onboard testing is vendor support, since certain action points, such as user access, privilege management, and remote access, cannot be verified without vendor engineers. On the other hand, items such as physical security and cable protection can be verified independently on site, and penetration testing is conducted within strictly controlled IP ranges. From this project, several key lessons were identified, including the importance of understanding the location of zone boundary devices in advance to improve efficiency. For example, systems like ECFIS and S-Vessel use firewalls integrated within the VDR for external communication, and identifying these interfaces enables faster execution of port scanning, while also highlighting the need to verify the latest asset inventory due to possible software changes after commissioning. This concludes our case study on Lloyd Cybersecurity Established Level 1, demonstrating not only compliance, but also how cybersecurity is practically implemented and validated in a real shipboard OT environment. If you have any further inquiries, please feel free to contact the SeaNet cybersecurity team. And thank you for your attention. Our comprehensive cybersecurity solutions are designed specifically to meet the unique demands of maritime environments. Our dedicated team is available 24/7 to address any threats you may encounter at sea. SeaNet stands for Sea, Earth, Air Network, creating a world that connects the sea, earth, and air. Please subscribe to our channel and hit the like button to access more high-quality educational videos and stay updated on our latest training sessions.